Hey, this is Jordan, and this video I'm going to go over the limitations of HDL Coder using the example of recreating a demo Blinky project that came with this dev board. So, let's jump right in. First off, here is me recreating this project, this idea that came with the board. I'm first just going to show it simulated because it's a lot easier to show than to explain with words. So we've got these two. This top flowchart corresponds to this subsystem, this bottom flowchart corresponds to this subsystem. They operate very similarly, and they will still be blinking LEDs, but it'll be a bit different. So, assuming nothing's pressed, what will happen is we have our red LED that will flash on and off, and our green LED will be twice as fast as our red LED. And then, this is the beautiful part about Simulink and Stateflow, is that during the simulation we are able to adjust the inputs. So for both of these subsystems, there's a button that when pressed on the real board is supposed to double the speed of the current LED. So for this one, when I flip this toggle switch, which Simulink makes very convenient, this toggle switch is tied to this constant block, and that goes into the subsystem, which is right here, which goes into the chart, which is labeled, in here it's labeled button 2, but in here it's just labeled button. So when we flip this, if you noticed before, like I said, this was running twice the speed, this chart, as this one, but over here this is now running at the same speed as this one. And again, if we flip this button, this chart will flip over to these two states and will go twice as fast. And then if we ever want to, we can reset, which both Stateflow diagrams will jump to the center, and then we can make any adjustments we want to the inputs and let her go, and they'll go back to doing their normal thing. So this is the demo Blinky project that came with these demo boards. They did a more thorough job than this because they probably and hopefully coded it up in VHDL and not in Simulink and HDL Coder. But right now I'm going to jump a bit more into this Simulink and what I made and why, and then I'm going to show you the limitations as we drag it into Libero and all that jazz. So, like I said, for each of these, they're almost identical. The only real difference is in this red chart we've got, and these all are taken down by 2 orders of magnitude so you could see the difference. In the real one, this was at 50,000, 50 million, 25 million, 25 million, 12.5 million, but for convenience I took them down. So that's really the only differences are the speeds. They all have frequency 1 LED off, frequency 1 LED on, frequency 2 LED off, frequency 2 LED on, and then a reset state. So for the transitions, this Stateflow is significantly more complex than the first one I showed in this video series. These, for example, this state has 3 transitions coming out of it, and they're labeled by 1, 2, and 3, as you can see. Simulink and Stateflow are wonderful because they give the option to prioritize which transitions should be checked first. So for this flowchart, I've got 2 input variables. One is button and the other is called both. So the idea is that when we default and start this Stateflow running, it'll default into this frequency 1 LED off state, and the very first thing it checks is this output transition, which is to check to see if we go to reset. The second one is to check to see if we jump over to this second frequency that mirrors the first frequency. And finally, if neither of those conditions are true, then we just wait the ticks and then we come and we toggle. This is really useful because in making these diagrams, which it took a little bit of time and me standing in front of a whiteboard and thinking through how to set these up, so I didn't just whip these out within a couple of minutes, it took me some thought. But this allows these transition priorities. In both these cases, you can see that every one of my priority transitions always goes to the reset. This is really nice because this made it so that at any point in the system, the reset should always reset it immediately, no questions asked. The second priority for all of these is to transition from the one frequency to the other. Notice the 2 here, the 2 here, the 2 here, and the 2 here. So first priority is the reset, second priority is swapping back and forth between the frequencies, and then the third priority is to actually flash the LEDs. So the beautiful thing about programming FPGAs is you can have multiple state flows and multiple processes truly running in parallel. They'll be running off the same clock, but they'll be doing completely different things, or they can be. In this case, they're doing very similar things. But Stateflow and Simulink are beautiful because they allowed that simulation, and you can test your inputs, and you can see if your state makes sense, and you can check to see if anything ever gets into a very interesting state. Now, the thing that I was imitating here, it didn't actually have here in the reset section in both of these. I put an entry and an exit this time, which is more than the previous example I did in Stateflow. And I inserted a debug light because I was getting some interesting things and I wanted to know when I was specifically in the reset state and when I was just in the off state. So for both of these examples, I have two inputs, one if the corresponding button to the LED is being pressed and one if both buttons are being pressed. And then in my demo board, each LED array has one green LED and one red LED right next to each other. So for the red subsystem, it normally blinks a red light at either frequency. And then I have this set up so that when it goes into the reset state, it will turn on the green LED that's just adjacent to the red LED. So this is what I did. It kind of looks a little hairy, but it wasn't too bad. I tried to specify these variables as being equal to true or false to make them Boolean, and it mostly worked, but as we'll see, I'm going to jump over now to Libero, and we had a couple of issues when I tried to make everything work here. So this is already created, I already flashed it onto the board. I'm just going to run over the idea and the thought process behind it, and then again talk about the limitations of HDL Coder. So similar to the Stateflow setup we had in the top level diagram, I have the red chart here and the green chart here, which was the same as previous, and then the clock, the reset, and the enable are all tacked the same as the previous example video that I did. Then I have the both and the button inputs for both of these charts, and then I have the light and the debug light coming out to all these separate lights. So the couple of key differences here, I labeled these as button 1 and button 2. Button 1 corresponds to the green, which then I labeled the outputs as LED1 green, LED1 red. So when button 1 is pressed, you can follow that to the button input, and when button 2 is pressed, you can follow that to the button input of this separate chart. When both are pressed, and this is wonderful and why smart design is great, I just threw in an AND gate, and then I connected this up to both inputs of both charts. So it's, again, very similar in concept to the previous design, even though it's a tad more complicated. The only problems with this was coming straight out of HDL Coder. I'm going to switch over to a view of the actual generated HDL code, which worked well with one exception. Here we see this both and the button variables are declared as standard logic, but the comment next to them is double. So I tried to, in the Stateflow, declare them the same as, the lights, and have that all be the same, but in here they came out to be real variable types, which correspond to doubles in VHDL. So I had to, when I brought them into Libero, I tried to pull them in and it said I had a syntax error. So I came in here, I had to change, after doing a little snooping, the types to be standard logic, and then for all of these down here, instead of being if both is equal to single quote 0 single quote, it was 0.0. And so that difference made a big difference whether or not the code was valid. So I went through and altered all of those. And then when I did that, I was able to complete my smart design diagram and then follow the same process of generating, synthesizing, going through the I/O constraints, the managing the constraints, place and route, and then running the program action. This program works very well, but again, like I said, I put in a debug LED to see when I was in the reset state. And if you act like a normal human being with this design, then it works great, just like the Simulink version worked. But the problem is, coming back over here to all of our Simulink and Stateflow designs, in the real application, if I am pressing the buttons really quickly, either button number 1 or button number 2, or if I press them both together and reset it quickly, then it gets into very, very interesting states that and I'm trying to show you by clicking, but software is very different from the hardware implementation. Anyways, it gets into interesting states that by these Stateflow definitions, it shouldn't. For example, I've gotten it to where the debug light is on as well as the regular light is oscillating, which, according to how I've set this up, it shows that when you enter this reset state, it'll turn it on, but whenever you exit, it should always turn that light off. But if I'm being very particular with it, it messes it up. The original project does not do this, the one that came with the board. So the takeaway from this video that I'm trying to make is, 1, when making things in Simulink and Stateflow and exporting it through HDL Coder, it isn't as precise as you might want it to be with the different variable types and how you write the code. And by extension, I had to read through and try and figure out what was going on in this generated code, which wasn't nearly as easy. It was easy in this case, but it might not have been as easy because it wasn't my own code. And 2, it doesn't necessarily implement it how you would think. So because of these reasons, for my specific applications of using HDL Coder, using Simulink and Stateflow, and using Libero, it is best to use Stateflow and Simulink as a way to both document and to test your idea of how things should run, but actually coding these state machines up in VHDL is the better option because you will have full control over all of your variables, all of your states, and it should be easier and better to debug when you get down the road and you find issues like the ones I found. Anyways, that's it. Thanks for watching.